Counting sort. Counting sort is a non-comparison based sorting algorithm which is useful for sorting under two conditions. So let us understand what are the two conditions under which counting sort is useful. The first condition says that the data that is to be sorted using counting sort should either be integers or it can be some objects that can be mapped to integers. What did I mean by objects that can be mapped to integers? What I meant is sometimes your data will be integers itself, that is values like 1, 2, 3, 4, etc. Sometimes you may have some other data, but it will be possible to find the mapping, one-on-one mapping for all those to the integers. For example, if you are having alphabets, then A, B, C, D, etc. can be your data, but this data you can map to integers. How? A can be mapped to 1, B can be mapped to 2, C can be mapped to 3, D can be mapped to 4, and so on. So in this case, you can map it to integers, apply sorting on the integers, and then you can take it back to whatever was the original data. So this is the first condition. Either it should be integer or some objects that can be mapped to integers. What is the second condition? Second condition says that the range of values that you can have, this should not be significantly larger than the number of elements in your data set. So in case number of elements is much lesser than the range of values, then counting sort is not applicable. Counting sort is applicable only when the range of values is comparable to the number of elements, or even better, if the range of values is lesser than number of elements. What did I mean by this? Sometimes it can so happen that the range of values that your elements can take may be from 0 to 100. And the total number of elements, so this is the range, and total number of elements you are having, number of elements can be 100. So in this case, the range of values is comparable to the number of elements. So you can use counting sort here. But there may be cases in which the elements that you're having, that may be allowed to take values from 0 to 10 power 10. So it can take all these larger values. But total number of elements you are having, that may only be 100. So in this case, range of elements is much larger than the number of elements. These cases you should not be using counting sort. So the two conditions are, one is it should either be integers or objects that can be mapped to integers. Second condition is range should either be comparable to the number of elements or lesser than number of elements. So considering that both these conditions are met, let us see how counting sort is applied. One more thing, why is this called as counting sort? The name is interesting, counting sort. Why is it called so? The reason is, generally when we see comparison based sorting and all, what we see is we compare different elements in the data set and then we will find out which one is smaller, which one is larger. But in case of counting sort, what we do is whenever you have any input array, we'll count the occurrences of each value. We'll check what is the value in each of the input elements and we'll count the occurrences of each element and we'll track the count of all those. So by this time you would have understood somewhat that this algorithm is better if your data is having the same value repeated at multiple positions. So in that case, you can easily take count of all those and then sort. So you'll take count, you'll keep track of the count of different elements, and then this count is what you're going to make use in order to sort and find final sorted list. So this is why it is called as counting sort. So let us understand how counting sort works. What is the procedure? We'll start from the input array. You are having this as your input array. Assume this is your input array. So there are a lot of elements in your input array. What is the first thing to be done? First thing to be done is to identify the range. How will you identify the range? You will first find out whatever is the least element or minimum element that is present in your data. Second thing is you will find whatever is the maximum element in your input data. Once you get the least value and the largest value, minimum and maximum element, you can find out range from this. So from this you can understand what is the range of your data. So this is the first step. What is the next thing to be done? The next thing to be done is you have to create a count array. So this count array will be used for keeping track of the count. So you will create a new array called count array. So I'll call this A, whatever is your initial array, and whatever is the count array, I'll call it C. So C is the count array which is supposed to keep track of count. Next thing is you have to initialize all values in count array to 0 and then start traversing the input array in a linear manner. So you'll start from the first element of input array. You'll keep traversing till the end. While traversing, what you'll do is you look whatever is the value of the value inside that particular position. Whatever be the value, there will be one element in this count array. There will be one index which is corresponding to the value present in this particular input array. Whatever be that index, for that index you will increment the count. From 0 it will become 1 if this is the index that is corresponding to the value present in first element of A. So that will get incremented. Again you will go into second element of A. Whatever be the index corresponding to that in count array, you will increment the value. Let us say this one. Similarly, you will look into each of these and corresponding to that you will keep increment the value of count in the count array. So let us assume that you completely went through and the final values look something like this. This is 2, this is 0, 1, 3, 2, let us say this is 2 and then 0. We'll provide indices here as 1 or let us give from 0, 0, 1, 2, 3, 4 and 5. So we are assuming that the range of values in this array is from 0 to 5. So whatever be the values here, they can take values only from 0 to 5. So maybe values are 4, 3, so on. So what we'll do next is, see at this point you may think the algorithm is finished because by your common sense, you know that if you have this count array, you know this is the range, you can directly find out the sorted array because it's very simple. You know 0 is occurring 2 times. So just write 0 2 times. You know 1 is not occurring. 2 is occurring once. So simply write 2 once. Then 3 is occurring 3 times. So write 3 3 times. And then 4 is occurring 2 times. So write 4 times. And you know 5 is not occurring at all. So that is it. This is your sorted array. But this is not the counting sort technique. There is something more to be understood. So it looks like this can directly give you the final sorted array, and in one sense it is right, but the counting sort algorithm uses some additional technique in order to add some extra features. So that is where counting sort becomes special. So this is not how you find the answer. There is something more to be done in counting sort. So let us understand the exact technique. What more is to be done? So what I'll do, I'll first tell you the procedure, what additional we are going to do. Why is it being done? I'll explain at the end. Till that point, try to think and come out on why we are doing this procedure, okay? Because this procedure is very logical and it is the core part of counting sort. The next thing I'm going to do here is, so just try to keep thinking and try to find out why I'm doing all this procedure, okay? Because I already showed you, you can directly find out the final sorted array simply from this count. But why am I doing this remaining procedure? You have to keep thinking. After that, I'll tell you, okay? So the next step is, I have to find cumulative count of all these. So what is cumulative count? At each of these positions, I should have count of all the elements till that point. So what I'll do, I'll not erase this array. Ideally, you will just increment all the cumulative, change all the counts to cumulative count. I want you to see this array as well as cumulative count array. So for that reason, I will keep this array as it is and put an additional cumulative count array. So in this cumulative count array, I'll just put cumulative count. So till this point, 2 is the total. This is 0. So again, 2 is the total. Plus 1 will give 3 as the total. Plus 3 will give 6 as the total. Plus 2 will give 8 as the total. Plus 0 will give 8 as the total. So this is the cumulative count array. So after cumulative count, the next step is I am going to traverse the input array again. So whatever is my input array, this I am going to traverse again. So this is the core part. So why should I traverse again? This is one question. What am I going to do now? When I'm traversing again, I'll traverse in reverse order. Initially, I started from left and went to right while taking the counts. But this time, I'm going to traverse in reverse order. And whatever is the output array, I'm going to construct a separate array for output. This is my array B. I'll create a separate array B for output. And while I want to write something onto B, what I'll do is I'll traverse A from the right side towards left, that is in reverse order, and then again start looking at each elements. I look at the first element, I saw it is 4. What I'll do, I'll come to the index 4. So what does index 4 say? It says 8. So because index 4 says 8, what I'll do is, okay, here I'm having lesser elements, so I should add more columns here. Think this is having index 8, okay? And so here I'm only having lesser number of elements in the array. If this is my index 8, what I'll do is, because 4 is saying 8, I'll put the value 4 in index 8. In index 8, I'll put value 4 and I'll decrement this to index 7. So when I already put one element, I'll decrement the value of index. And let us say there is a 3 here, okay? So the next one is 3. So I look whatever is the index of 3, it says 6. So if this is 8, then this should be 7, this should be 6. So I'll go to index 6 and put the value 3 because 3 is 6. So I'll put the value 3 here and I'll decrement the value of 6 to 5. Again, I'll look into the next element. It also says 3. So this time 3 says 5. So I'll put in 5, I'll put 3. Then again I'll go to the next element which is 4. 4 says 7. So I'll put 4 in 7 and decrement this value to 6. So why am I doing this? Like this, if I construct the complete array, I will get complete sorted array in this array B. But the reason, I told you I'll tell you the reason why we did this cumulative sum, and then we again went to the input array and traversed it from the back side. The reason we did all these in order to maintain stability of sorting. So by doing all this additional procedure, we were able to maintain stability. How did we maintain stability? If you think, if we directly found out the sorted array from this, that is from the counts that we have, if we directly found out sorted elements, let us say you want to write zeros. How will you write? You will simply write 0, 0. But you have no idea of which among these two zeros occurred first in the actual array. Whatever was the actual array that was given, you have no way of differentiating these two zeros. But in present case, when you are again looking into the actual array, what are you doing? You are first looking whichever is the last occurring 4 in the actual array. Corresponding to that, you are adding the entry in the last element of the sorted array, which means whenever you will have two elements of same value, the order of those elements will be maintained as it is in the sorted array. Because of this, you are able to maintain stability. It becomes a stable sorting algorithm once you are using all this additional procedure. So in order to maintain that stability, we are taking this cumulative sum and then again traversing through initial array. So this procedure is for maintaining stability. What we'll do, we'll take an easy to understand example so that I want the whole process to be crystal clear for you. So for that, we'll take an example. Instead of numbers, we'll take tuples. So from that, it will be easier to understand the concept of stability. What I'll do is, instead of taking simply numbers, we'll take data like this. 4a, this is a tuple. 3b, this is another tuple. Let us say 6c, 5d, 7e. So this is your input data, okay? You want to sort this data. Let us say you have 3f, then maybe you are having 6g, 4h, and one more element we'll have 4i, okay? These are the elements you are having. So this is your input data. This is your input data. I'll call this input as array A, okay? So how can I write this as an array? I'll have to put all these values in an array so that it makes sense, or I'll just put indices here. Okay, just imagine that this is an array 3, 4, 5, 6, 7, 8. Okay, so think this is input array A. Okay, I have put indices there. Okay, this is your input array. What is the first thing you want to do? You want to find minimum and maximum values. What is the minimum value here? Minimum value among all these. So you have to sort according to the number. Okay, whatever alphabets I put so that you can identify different in entries having same number. For example, there is 4 here, 4 here as well. But this is for H, this is for I. So I want you to differentiate all the values which are having same numbers. Okay, this is what we are going to do. We'll take range. Minimum value is 3, maximum value is 7. So minimum is 3, maximum is 7. So the range of your input is from 3 to 7, which means how should you have your count array? Your count array, what is the total number of elements that should be there in count array? So 3 to 7 means 7 minus 3 plus 1. This is the total number of elements you should have. So this is 5. So here you have 5 entries, 0, 1, 2, 3, 4. What you will do is all your 3's will be mapped to 0. 4 will be mapped to 1. How are you doing this? Because in order to find the index in count array, what you will do, whatever is your actual entry in array A, you will do minus 3 to that. So if you have first entry as 4, 4 minus 3 is 1. So 4 will get entry in 1. Okay, this is what you are going to do. So what is the first step? You have to create this count array. You have to traverse array A from left to right. While you are traversing, you want to increment count. How will you increment count here? First entry is 4A. So 4 minus 3 is 1. So you will increment count to 1 in this. Next entry is 3B. So for 3, the entry should be 3 minus 3, which is 0. So I'll increment 0 by 1. Next is 6C. 6 should get 6 minus 3 is 3. So 3 will increment. 5D. 5 minus 3 is 2. 7E. 7 minus 3 is 4. Next is 3F. 3 minus 3 is 0. 0 is made 2. Next is 6G. 6 minus 3 is 3. So 3 is incremented to 2. Next is 4H. So 4 minus 3 is 1. So 1 is incremented to 2. Next is 4I. So 4 minus 3 is 1. 1 will be incremented again. So 1 is incremented to 3. So this is your count array. 2, 3, 1, 2, 1 is your count array. Next step, you want to find cumulative counts. So with the same count array, I am going to have cumulative counts 0, 1, 2, 3 and 4. What are the cumulative counts? At 0, you have total 2. 2 plus 3 is 5. 5 plus 1 is 6. 6 plus 2 is 8. 8 plus 1 is 9. So this is your cumulative count array. What is the next step? Next step is to build final array called B. So I am going to build B here. How will I build B? I have to traverse A from the right side. From the right side of A, I'll keep traversing towards the beginning, from the end to the beginning. So what is the rightmost element? Rightmost element is 4, 1. So if 4, 1 is the rightmost element, what should I do? Corresponding to 4, the entry will be 4 minus 3, which is 1. So index 1 will tell me 5. So I should put in entry in 5. What I'll do, I should have total of 9 entries. So I will draw this. I'll do this. One, 2, 3, 4. Okay, I should have it a bit more larger. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. 8, 9. Okay, I should have 9 entries. And I should have indices from 0, 1, 2, 3, 4, 5, 6, 7 and 8. These are my indices. So what I'll do, I'll check the last element. Last element is 4, 1. So corresponding to 4, so this is no more valid. Okay, I'm only using cumulative sum. I won't use initial count array. So 4, 1. So corresponding to 4, what should be my index? My index should be 4 minus 3. Why minus 3? Because my minimum value is 3. 4 minus 3 is 1. At index 1, I have 5, which means I should go to fifth element in the output array. So fifth element will be having index 4. Okay. In index 4, what I will do, I'll put the value 4i. So 4i. This is present in index 4. Then what I'll do, whatever is this I'll decrement to 4. Next step is go to the next element. It is 4h. So again it is 4, which will come down to index 1 in this cumulative array because 4 minus 3 is 1. It says 4. So the fourth element is having index 3 because our indices are starting from 0 in the output array. So index 3 says we should input this here 4h. So I'll put 4h. After this, I'll again decrement this to 3. What is the next entry? 6g. So 6 minus 3 is 3. So I should look at 3. It says 8, which means 8 entry, which is at index 7. So here I should put 6g. 6g will come here. Next entry is 3f. So 3 minus 3 is 1 minute. For this 6g, I have to decrement. So 6 is corresponding to 3. I have to decrement this to 7. Next is 3f. So how will I deal with 3f? 3 minus 3 is 0. 0 says at index at element 2. So second one is index 1. Okay. 2 minus 1 is 1. So at index 1, I'll put 3f. 3f. What I'll do, I'll decrement this to 1. And the next thing I have to do, so 3f is also done. Next is 7e. So what is 7? 7 minus 3 is 4. Fourth entry in cumulative array says 9. So I should go to ninth block. Ninth block is having index 8. So at index 8, I should put 7e. 7e comes at index 8. After this, I have to decrement this to 8. Next is 5d. 5 minus 3 is 2. I'll go to 2. It says 6. 6 means I should put in fifth box. In fifth box, I should put 5d. And 6 is decremented to 5. Next is 6c. 6 minus 3 is 3. I'll go to third index. It says 7. Seventh block is having 6 as index. So it will be 6c. So I'll decrement this to 6. Next is 3b. I'll do 3 minus 3, which is 0. So I got 1, which is the first block. It will be index 0. I'll put 3b here. 3b. And then I'll decrement this to 0. Next one is 4a. 4 minus 3 is 1. It says third block. Third block is index 2. Index 2, I'll put 4a. So at this point, and I'll decrement this to 2. So at this point, my complete input array I have traversed through. And when I traverse through the complete input array, my output is also completed. So just check out this output. This is the sorted array plus it is stable. So if you see here, let us take 4 as an example. Okay. In 4, 4a comes before 4h and 4i, right? So 4a, 4h, 4i is the order in input array. If you see output array, the same order is maintained. 4a, 4h, 4i in input array, 4a, 4h, then 4i in output array. So this is a stable algorithm now. So this is why we are doing those extra efforts for counting sort. Next thing we'll do is we'll see the pseudocode and then we'll analyze time and space complexities of this algorithm. Okay. So let us write pseudocode first. That will give us more clarity. Moreover, when you know an algorithm, you should be able to write the pseudocode correctly because then only you can say you know all the steps accurately, right? Moreover, this is also telling you that you can convert it into code, right? So that is the ultimate skill that you want. Let us write the pseudocode for counting sort. So counting sort, what should be available as arguments? One is you should have input array. We'll use the same names for the arrays that we used. We used A for input array. We'll use the same thing. B for the output array. So this is where you will output to. Then you should have minimum and maximum keys. Okay, so in previous example, 3 and 7 were the minimum and maximum keys. So for that, let us have K and Q now. So K represents minimum, Q represents maximum. Okay, so this is the counting sort algorithm. So what should be the first step? First step is to find range. Okay, so you have to find range. Range is K, which is okay, if K is minimum, or let us I wrote K first, so let K be maximum. Okay, K minus Q plus 1. So in this case, K is maximum, Q is minimum. Okay, so then only you can do K minus Q. So range is K minus Q plus 1. So K is minimum, K is the maximum value in your array, Q is the minimum value in your array. Next thing is you want to create count array. Okay, so I'll call it as C. C is your count array. Count array should go from 0 till your range minus 1. Okay, this should be your count array. What should you do? You should initialize count array to 0. So all the elements should be zeros in your count array. Next thing is you want to populate this count array. How do you populate? You want to go through the array A, and while you are going through, you will scan through each element and find the number of occurrences. So for each key, or okay, I'll just write for each key in A, in the array A, what will you do? You will update count array. So count of, so for each of the keys, what will you do? Whatever key means whatever is the value of element in A. For count of key minus, what should be key minus? Key minus your minimum value. So Q is your minimum value. Key minus Q. This should be equal to count of. So what you are doing, you are incrementing. You should do count of key minus Q plus 1. So whatever be your count array value, you should increment that by 1 whenever you see an element in input array A. So while you are scanning through A, whenever you see an element, the corresponding value in count array you have to increment by 1. So this is how you are going to maintain the count. Okay. The next step is you want to, now you already found the count array. Next thing is finding the cumulative count array. So how will you make this count array as cumulative counts? You will do for I is equal to, what values will I take? From 1 to range minus 1, whatever is your range. So 1 to range minus 1. What will you do? You will take the count array, take count of I is equal to count of I plus count of I minus 1. So you are taking the count as addition of this plus count of the previous element. So this is how you will find the cumulative sum. So after you find the cumulative sum, what is the next step? Next step is you want to go through the initial array from the end to the beginning. While you are coming from end to the beginning, what should you do? You should see first you should identify what is the key inside the element. Corresponding to the element, you should check whatever is the entry in count element, that is cumulative count array. Once you find that, you should from that produce the final output array. So let us do this. For I is equal to, what is your initial array? A. So A dot length, let us say this says what is the length of A? A dot length minus 1 to 0. Why am I doing this? Because A dot length minus 1, that is the last element in A. So this is my input array A. I want to go from the last element of A till the first element, which is having index 0. So I'll start from the last element and I'll go till the first element. So when I'm doing this, what should I do? I'll first see what is the key. So key means whatever is the value present inside. So key is equal to A of I. So this is in the first iteration, this will be the last element. Once I get the last element, I have to identify the index of that. How will I identify the index? Index is equal to, so index means index in the cumulative count array. Whatever index should I be looking into in the cumulative count array? That index will be key minus whatever is by minimum value. Minimum value is q. So this will give me the index I have to look for in the cumulative count array. What is the next thing? I have to check the index in cumulative count array, and according to that index that I get from cumulative, according to the value of the index that I get from cumulative count array, I have to update the value in output array. So my output array is B. So let us directly put it in the output array. B is my output array. In my output array, which index should I add into? I should see the cumulative count array. From count array, I should do index. So here I know the index of count array to look for. Index minus 1. Why am I doing this minus 1? Because we saw that in the example also, array B was starting at 0, which means we have to do a minus 1 in order to find the block corresponding to that particular element. So from cumulative count array, we know the index that is to be checked. Then you do minus 1 so as to find the index in the output array where you have to enter. So this should be filled with whatever is your key. So that is your key. Once you do that, what is the next thing? The count array you have to decrement. So your count array C of index has to be decremented. This is equal to count of index minus 1. So you decrement it. Once you do this, once you come out of this loop, what will happen? Whenever you complete all elements of the input array and you come out of this loop, at that point, your complete output array B is constructed. So you can return whatever is B. So when you're done with this, you can return B. So this is your counting sort algorithm. So let us go through this from beginning and understand clearly. What did we do in counting sort algorithm? First we found, so A, B, K and Q, these are the input array, output array, K is the maximum and Q is the minimum value in your arrays. And what did you do with the range? With your range, you found out the range as K minus Q plus 1. Then you made a new count array. Your count array is initialized to all zeros. After that, what did you do? You populated the count array by looking at the initial input array A. So you went through the input array A from left to right. While going that, you checked each element. Corresponding to each element, you updated count array. After updating count array, what is the next step? You had to find cumulative counts. So you went through the count array again in order to update with cumulative counts. After that, what is the next step? You want to populate output array B. How did you populate it? You went in reverse order in the input array A. While you were going in reverse order, in each element, you found out what is the key. Then from that, you found what is the index to be looked for in the cumulative count array C. Then in order to populate array B, that is the output array, you went to the cumulative count array and the corresponding index. Minus 1 on that will give you the index to be populated in B. So in that particular index, you put the key that you retrieved from input array A. After that, you have to decrement whatever is the index you used from the cumulative count array. You do this for all the elements of A in the reverse order, that is from right to left. You do it for all elements of A. At the end of this loop, you will have complete output array B, which is sorted. So this is about counting sort. Next thing is, what are the time and space complexities of this algorithm? So in order to understand time complexity, let us see what are the most time-taking operations here. So one thing you have to keep in mind is, you have to go through the array A, that is the input array, 2 times. Once from left to right, second time from right to left. That is the only time you are going through array A. Which means for that operation, you will need order of n time. Right? You are going once from left to right through A. Again, you are going once from right to left. So that will take order of n. What is the other time consuming operation? Other time consuming operation is that you want to construct this count array and update. So when you're constructing count array, you want to have whatever be the length of count array. That is the total time you will take. So that is according to the range. So for that, order of whatever is your range let us call R. So whatever is your range, for that, according to that, you have to build the count array. So because of this, total time taken is whichever is larger, total number of elements or the range, whatever is larger, that will be the total time taken. So because of this, your time complexity of algorithm will be order of n plus r, where r is the range of your values, n is the number of values you have. So that is why we initially said if the range of your values is comparable to the total number of elements, in that case counting sort is very useful, because this will come down to order of n. If you use any of the comparison based sorting, best case you can do is order of n log n, and you can't do a better sorting than order of n log n in case of comparison based sorting. But in counting sort, if the range is similar to n or if the range is lesser than n, in both these cases you can do in order of n time, otherwise it will be order of range. So order of n plus r is the time complexity, which means if range is comparable to n or if range is lesser than n, it is effectively order of n only for time complexity. What about the space complexity? In space complexity, what are the additional spaces used? One is the output array. So for output array, you want order of n additional space. What is the second thing? The count array. That is also what you are newly using. So count array will take whatever is the space of the range. So order of range is taken by count array. So what is the total space taken? It is also order of n plus r. So depends on output array and count array. So in case of counting sort, both the time complexity as well as the space complexity are order of n plus r, which also means if the range is comparable to n or if range is less than n, both these cases, your time and space complexity both will come down to order of n. The last question is it an in-place algorithm and is it a stable algorithm? So it is not in place because you are using additional space. You are using B as an additional array. You are using counting array separately and you are doing the counting process in those arrays. You are not doing from the main array. So because of that, it is not in place algorithm. It is out of place algorithm. It is out of place algorithm. What about stability? Yes, we clearly discussed about how it is becoming stable when you did all those techniques in counting sort. So it is stable and out of place.